Okay, this chapter, or assignment number 7, was for 2A ANOVA. So, like all the other chapters, they will discuss the assumptions and all of that. Now, in this question, they're going to test two different factors. Direction, also called slope, and there are two levels, east and west. The other factor was elevation, and they had 3 different levels: elevation A, elevation B, elevation C. I believe this was at 2,000 feet, 2,500, something like 3,000 feet. And they want to see if any of them has effect on mean of micrograms of lead per gram of moss tissue. For population of all fern moss specimens. Now, the first question, this is the story. This is what they, sorry, this is what the question is about. Now, the first question was at 5%, does direction or slope has an effect? So only asking for one of the factors, does it have an effect? Now, in terms of H0, HA, H0 is always the negative language. You say whatever the name of the factor is, so has no effect on mean of microgram of lead tissue, so all the way till you get to the word tissue, so has no effect tissue. Now you have to mention this is new, following the elevation, which is factor 2. So they ask you for one of the factor if it has an effect or not. So you start with the name of the factor, has no in H0, no effect on the mean of whatever the question is about. Following the elevation, which is following factor 2, for the population of all the sample. Fern moss specimen. And these slopes, so you have to name what the factors are or the levels are. These slopes, east and west, and these elevations, which is factor 2, the A, B, and C. So this is the complete way of defining your H0. You start with the slope, and the question has no effect on the mean of the question. Following factor 1 for the population of the sample, and these, now you name the factor and whatever the level is, and these you name the other factors and whatever the level is. HA would be the exact same thing, but positive, has an effect. Now when you go and look at the assignment, in some of the sections for the hypothesis, I wrote the H0 completely, and in HA, I didn't write it completely. I only said something like has an effect, blah, blah, blah. So for those, just fill in the information. It would be the exact same thing, but no, don't put the word no. This HA is always the positive language. Okay, now they wanted to see if what the conclusion is. Now, if you look at the results, you'll see that in the Minitab provided, I'll show you how the Minitab going to look like. It's going to look like something like slope, elevation, total, and at the same level of slope and elevation, you're going to see a T and a p-value. T would be the test, and p-value is the p-value. And for slope, I think it was close to 88%. You'll see that in the Minitab. So your conclusion, since p-value is 88%, it's definitely more than alpha of 5%. In this case, we do not reject H0. We do not conclude HA. And the results, of course, would be insignificant. And after this, we did not conclude. They asked for conclusion. Conclusion, of course, there was no talking about the assumptions. And since we have alpha, you say at 5% level of significance, we cannot conclude HA. But you put HA in words. We cannot conclude that slope has an effect on whatever till the end. Now, the other part was, what about if it was elevation? What if they ask about the elevation? The same story. Does elevation have an effect, which is the other factor? In H0, you start with the name of the factor. Elevation has no effect on the mean of all of this till the work tissue following the slopes, which is factor 2. So I'm writing this the same way I wrote the first one. I'm only switching the factors. For the population of all specimen and these elevations, and you name them A, B, C, and these slopes, and you name them east and west. HA would be elevation has effect. Now, to make the conclusion, you look at the p-value for elevation. And the p-value for elevation was also more than 5%. So again, it's insignificant, and do not reject, do not conclude HA. And in English, if assumptions hold at 5% significance, we cannot conclude HA, but again, you have to write it in words. And make sure, I don't know in which section I did the blah, 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 but when you read the answers, make sure that you write the HA and H0 and all of this in full sentences. Okay. And then there was another question for ANOVA, but this one is two-way ANOVA with interaction. They told you in the question they brought 15 students and year was one of the factors. Some of them in their first year, some in the second year, some in the third, some in the fourth. They're going to measure their relaxation or relax level. So they put them in a room, and the room had one of the three options regarding plant. They had live plant, they had photograph of a plant, and they had no. And that would be level 2. So this is factor 1, this is factor 2. So they want to see if factor 1 here has an effect on the relaxation level. They could ask if the plant has an effect on relaxation, or both of them, the interaction, meaning year and plant together, have an effect on the relaxation ever. Now, they showed a picture to see if yeah, they showed a picture with lines in it for each level, and they want to talk about the interaction. They could say, does the additive assumption hold? You look at the lines. Do they intersect? If they intersect, you say in the plot, and you name the plot, lines intersect, and if they intersect, then the additive assumptions does not hold. So it only holds if the lines were parallel. So if you see a picture and the lines are parallel, in this case they're not parallel. But when the lines are parallel, we say the additive assumptions hold. There is no intersection. Now, they also wanted to discuss the assumptions. One of the assumptions, the independence, and there are 2 levels of the independence. The actual sample must be selected randomly, and the assignment must be done randomly. So like meaning you select 100 students randomly, you assign randomly 20 of them to first group, you assign randomly 20 for the second group. So the main selection must be random, and the assignment of each group must be random. In this case, it was random, so the condition here holds. Then you got the equal variances assumptions. You'll see that there are the 3 major graphs, the versus, fits, where you see the points, and the normal, probability, where you see the line, and the histogram. Now, talking about the equal variances, you refer to the versus fit. Do you see the points spread evenly? Meaning that plot does or points do not thicken. Second, meaning if you see the points all in one section, so you see them together or most of them in one section, we call this a thicken. But if they're all over the place, that's fine. That's what we hope for. So they do not thicken. So again, this condition is also satisfied. There is the normal assumptions, or also called nearly normal assumption. You look at the histogram. In this one, the histogram wasn't perfect. So histogram was not symmetric. In this case, if the histogram not symmetric, you look at this graph. Do you see the points within a certain band? Like, you imagine now, you see the points like this? Are they within a certain band, or do you see outliers all over the place? The graph that the points look that they're within a certain band, then again, you could assume that this assumption is also met. Now, the other, then they wanted you to do the hypothesis of interaction. So here you say interaction has no effect the interaction between year and plant, which is factor 1 and factor 2, has no effect on relaxation of all students in this college or in this institute. So this one will be the no effect, and again this one there is an effect. Now, and the question asked for interaction or, no, I believe didn't ask for interaction, it asked for combination of some factors. So you start the combination between year and plant has no effect. This was asking for combination, which is a little bit different than interaction. Now, in the Minitab, when you look at the Minitab for this section, there is a Minitab of 3 lines only that has an f-test and a p-value. And there is another Minitab, or another section in the Minitab, that has other information. Michelle, because I put some notes here, but again, my handwriting is not the best. So I'm changing my mind though. No, I think this was the interaction. Sorry. Yeah, this was interaction has no effect. Yeah, the combination was for the next assignment. So this was interaction, no effect, interaction has effect. So the Minitab, you have source, you're given plant, year, plant, interaction year, error, and total. You had degree of freedom, you had the SS, you had the MS, you had the F, and you have the p-value as well. I want to talk a little bit about the degrees of freedom. So we go to plant. Remember, plant had 3 levels: live plant, photograph, no plant. So the degree of freedom would be levels minus 1, so that would be 2. For the year, you had students in first year, second year, third year, fourth year. So this factor has 4 minus 1, 3. Plant versus year, you multiply these two. Gives you 6. This one you leave. You do this, the total. Remember, you had 15 students from each year. So from the 4 years, they tell you in the question that they had 15 students from each year, so the total number of students would be 60. So that would be 60 minus 1, 59. And since you know the degrees of freedom must add to 59, then you go, what is 59 minus 2 minus 3 minus 6? That would be 48. So again, for the plant, there are 3 plants, 3 minus 1, 2. For the year, there are 4 levels, 4 minus 1, 3. For the interaction, you multiply the 2. You leave this one. You go to the total in the question. The 15 is from each year, 60 students in total, making the degree of freedom 59. And you figure this out by going this minus the total. The SS, they give you all of them, but in the final exam, he might give you 4 of them. This one was about 4.5, this one 9.5. I'm only doing 1 decimal point. This was 30.4, this was 62.2, and let's say that this one was not given, and it could be any one of them not given, but you know that they should all add to the total. So again, you go this minus the three numbers, and that will give you something like 35.7 or 0.8. Now you don't need the total anymore. The total is only there to help you figure out everything else. MS, if you remember from single ANOVA, MS is always SS over degrees of freedom. So you take this over this. And 4.5 over 2 would be about 2.25. This over 3 would be about 30.5. This over 6 would be about 5.56 or 6, say. And this over this would give you 7.4. Now you go to the F. Now here, there are three F's to worry about. There is an F number for plant, there is an F number for year, and there is an F number for interaction. And remember, we always divide by error. For example, when you go to the first one, F, you take whatever the MS that comes with it over the error. So for this one, you go 2.25 over 0.74. And that gives you the first answer. So 2.25 over 7.4. And the answer here is 3.04. And for this one, same story. You take the MS over the error, 30.5, 7.4. That gives you 41.216. And for this one, you also take the number over the error, and that gives you about 7.567. P-value in the question given, and I believe it was 0.0800. Okay. These numbers are not exactly the same Minitab because I'm rounding to 1 decimal point, but I just wanted to show you how it works. Then they wanted to know what test to use. We know it's the F test. But since this one is for interaction, you pick the one for the interaction, which is this one. So that would be the value. The one in the Minitab was exactly 7.47. This is just an estimation of the number from my calculation. And p-value would be the one next to it, the 0.00. Now, what's your conclusion? First of all, they wanted you to talk about strength. P-value of 0.000 that's less than 0.001. So you have strong evidence for HA. And what's the conclusion in English? You say, since assumptions hold, we have strong evidence to support HA, but you don't say HA, you say what HA is in words. We have strong evidence to show that the interaction has an effect on the relaxation for all students, or the interaction between ear and plant has an effect on. This was assignment number 7, so review it. Make sure that you read my answers and follow. If I have in one of the sections the blah blah blah, you put it in full sentences, and you should know how now. But this is it for assignment number 7. The next one would be assignment number 8 as a last assignment for multiple regression.